Alright, so in this video I'm going to talk quickly about a few common rules of differentiation and also the partial derivative, okay, which is a partial differentiation where you want to differentiate a function of two or more variables with respect to one variable, okay, that is called the partial derivatives. So we're going to go through a little bit just to get you guys to be familiar with a very common sort of differentiation stuff before we going to more of the exercises about marginal utility and marginal rate of substitution, which is just basically about differentiation, okay. So there's a few rules that you would have to bear in mind. So the first one is called a constant rule, okay. This is very straightforward rule where it's saying that when you differentiate a constant with respect to a variable, you get 0, okay. So if I got a function y of x equal to a constant c, then when I differentiate this function with respect to x, okay, I get 0. So that's a constant. So whenever you differentiate a constant, you get 0, okay. Now the second rule is called a scalar multiple rule. Now this is very straightforward as well. So if you got a function y as a function of a constant, okay, multiply by a function of x, so c multiply by z as a function of x, okay. So if you want to differentiate function y with respect to x, okay, then the constant is going to remain the same, okay. So c is just going to remain the same as c, and you just have to differentiate the function z with respect to x, okay. So basically the rule is just saying that whatever a constant in front of the function is going to remain the same there, so it's going to stay there, okay, and you just have to differentiate the function of x. Okay, the third rule is the power rule. So if you got a function y as a function of x equal to x to the power a, then when you differentiate this function with respect to x, the power is going to be moved to the front. You multiply by x to the power of the original a minus 1, okay. So you minus 1 from the power and you move the power to the front. So that's the rule. Okay, now the third one is we got log, okay, rule, where if I got a function y as a function of x equal to the natural log of x, okay, then if I differentiate this function with respect to x, I get 1 on x. Okay, and now the next is going to be about the sum of functions rule. Okay, so if you have a function as a sum of other functions, how are we going to differentiate? So for example, if I have a function y as a function of x equal to y1 y1 function of x plus y2 function of x, okay. Now if I want to differentiate this function y with respect to x, then I just have to differentiate y1 with respect to x, and then I'll just plus the differential of y2 with respect to x, okay. So you just differentiate the functions separately and you add them together. It's very straightforward. Now if we got the function as a product of the two functions, how are we going to differentiate? So this is called the product rule, okay. So if I got y function as a function of y1 times y2. So I got function y as a function of the two little functions multiplied together. Okay, then if I want to differentiate this function, that it's just going to be the differential of the first function multiplied by the second function itself, so remain the same, plus the first function remain the same multiplied by the differential of the second function with respect to x. Okay, and that is the product rule. Okay, so for example, if I got, y as a function of x square plus 1 multiplied by log of x, for example. Okay, so if I want to differentiate this function with respect to x, what do I get? Okay, so how do I find the differential of this function? So basically, as you can see, we can treat this function in the bracket as a function y1 of x, and this is another function of x, so we treat that as y2 of x. Okay, so we know that the differential of y1 of x with respect to x, so if you differentiate this x squared plus 1 with respect to x, over here we are going to see that we got two the sum of the two functions. Okay, so the first one is x squared. If you apply the product rule, if you apply the power rule, you get 2x. Okay, now plus going to be plus, so if you apply the sum of functions rule over here, where you got 2, so if you differentiate a constant, you get 0, which is applying the constant rule. So that is just going to give you 2x. So that is the differential of function y1. Now the differential of function y2 is going to be equal to 1 on x, following the log rule. Okay, okay, so now we can apply the the product rule, and then we are going to get y dash of x is going to be equal to y1 dash of x, which is 2x, multiplied by the y2 function by itself, which is log of x. Okay, plus y1 function remain the same, which is x squared plus 1, multiplied by y2 dash of x, which is 1 on x. Okay, so this is our differential of the function y with respect to x, applying the product rule. Okay, now the last one is the quotient rule. Okay, sorry, second last one is the quotient rule, where if you got function y as a function of x equal to y, two functions divided by each other. Okay, so y1 divided by y2. Then the quotient rule saying that if you differentiate this function with respect to x, you get y1 dash, which is the differential of the function y1 with respect to x, multiplied by the y2 function remain the same, minus y1 function remain the same, multiplied by the differential of the y2 function with respect to x, and everything divided by y2 function square. Okay, so now we're just going to do a little example just to make it a bit clearer. Okay, so if I have yx equal to, for example, x squared plus 1 divided by log of x, something like this. Okay, so basically I'll be treating this as one function as y1 as a function of x, and I'll be treating this one as y2 as a function of x. Okay, so we know previously that the differential of the function y1 of x is just going to be equal to 2x, and the differential of y2 of x is just going to be equal to 1 on x. So applying the quotient rule, it is going to give you y dash of x equal to y1 dash of x, which is 2x, multiplied by y2 function by itself, which is log of x, minus y1 function by itself, which is x squared plus 1, multiplied by y2 dash of x, which is 1 on x, and everything divided by y2 function, which is log of x squared. Okay, so this is the differential of the function y with respect to x using the quotient rule. Alright, and the last one is the chain rule. Now this is very important. Okay, so chain rule is used where you want to differentiate a function y of x given that it is going to be a function of a function. Okay, so if y equal to y1 as a function of y2. Okay, so basically function inside the function. Then the chain rule is telling you that you want to differentiate this function y with respect to x. Then you differentiate function y1 with respect to y2. Okay. So I'll make it a bit clearer. So that is just basically we differentiate y1 with respect to y2 and we multiply by the differential of function y2 with respect to x. Okay, so y2 dash of x. Okay, so what does that mean? So I'm just going to go through a little example just to make it a little bit clearer. So for example, I have y as a function of x equal to log, which is a function. Okay, and inside over here, instead of just having log x, I have log of x squared plus 1. Okay, so something like this. Now, so if I want to differentiate this with respect to x, how do I do it? So basically, I'm treating the whole thing inside the bracket, inside the function log, as another function of x. Okay, so the whole thing over here, I'm treating this as a function y2 of x. Okay, and the whole log of y2 is basically the y1 function. Okay, and the whole thing over here is y1 as a function of y2. Okay, so what do I do now? So basically what I have to do is I have to find the differential of y1 with respect to y2. So when I say that, so I got y1 is equal to the function log of y2. Okay, because I'm treating the whole thing inside the bracket as a function, as y2. So basically y1 is just the log of y2. So when I differentiate y1 with respect to y2, remember, okay, then I get, now y2 is just a variable, it's not a whole, we are not treating that as a function of x, we're treating that as a variable. We just want to differentiate y1 with respect to y2 as a variable. So you can see if we differentiate a log function with respect to y2, we get 1 on y2. Okay, because we're treating y2 as a constant. Okay, and now so that's the first part. The second part is y 2 dash of x. So we know that y2 is equal to x squared plus 1. So if you differentiate that function with respect to x, you get 2x plus 0, which is equal to 2x. Okay, so therefore, applying the chain rule now, the differential of the function y with respect to x is going to be equal to the differential of y1 with respect to y2, which is 1 on y2. Okay, and multiply by the y2 dash of x, which is 2x. Now we know the function of y2. Okay, so we have to substitute that into here. So we know that y2 is equal to x squared plus 1. Okay, and multiply by 2x. So this is how we apply the chain rule to find the differentiation of a function inside a function. Okay. Alright, so now I'm going to go through a few very straightforward partial derivative of some useful functions, just to get you to be used to how to find a partial derivative, because it's very important to find the marginal utilities. Okay. So partial derivative is where we differentiate a function of two or more variables with respect to one variable. So basically, for example, I have function z as a function of x and y. Okay. So for example, if I got function z equal to x multiplied by y, okay, so I got a product function. Then if I want to differentiate z with respect to x, okay, which equals zx, which is the differential of z with respect to x, okay, then basically what I do is I treat y as a constant. Okay, when you differentiate a function of many variables with respect to one variable, then you're treating every other variables that you are not differentiating the function with respect to as constants. Okay, so if I differentiate, so if I want to find the differential of the function with respect to x, then I'm treating y as constant. Okay, so over here I just have to apply the constant rule, the scalar multiple rule, where I have a constant multiplied by x, which is a variable. So if I differentiate that, I'm going to get y. So the constant is going to remain the same, and the differential of x with respect to x equal to 1. Okay, so that is just going to give me y. So you're treating y over here as constant. Okay, so for example, that's just like differentiate a function z equal to 3x. So if you differentiate that, you get 3. Okay, so if you differentiate this with respect to x, you get 3. So in this case, you get y because we are treating y as constant. Okay, so very similar. If I differentiate this function z with respect to y, then I'm treating x as constant, and so therefore it's going to be equal to x. Okay, so now, so the next function, I would say z as a function of x and y equal to ax plus by, for example. Okay, so if I differentiate, I want to find the partial derivative of the function with respect to x, then I differentiate with respect to x, treating y as constant. So if I so I got the sum functions rule over here. Okay, where I got, if I differentiate ax with respect to x, I'll get a. Okay, because it's just a constant here. And plus, that's the sum rule. If you differentiate two functions adding together, then you just differentiate them separately and add them together. And if I differentiate by with respect to x, what do I get? Now remember, b is a constant, and if I differentiate with respect to x, I'm treating y as a constant as well. Okay, so the whole thing over here is a constant. And if I differentiate a constant with respect to variable, I get 0. So that will give me a. Okay, so very similar. If I want to differentiate with respect to y, then I'm treating x as constant, so the whole thing over here will become 0. And if I differentiate by with respect to y, I'll get b. So that will just give me b. Okay? Okay, so that's just basically to show you what we need to do for partial derivative. Okay, now more of these is going to be covered in the next exercise that I'm going to go through when I try to find the marginal rate of substitution by finding the marginal utilities. Okay, so in the meantime, you just have to practice how to do the differentiation. Okay, so make sure that you remember all the basic rules.